there are five parts. Part 1, part 2, part 3, part 4, and the last part is part 5, exponential and log and exponential. But for today, I just at the moment I just share four topics. The last topic, the topic number, the last part, part number 5, I will share later. I hope you can download this file from the UKM folio. Okay, let's start with function, section 1.1, concept and definition. Okay, I hope you can pay full attention in my class. Okay, the first concept here, I will explain about the domain and range. Let's say about the domain and range. What is domain? What is range? There's two basic definition you need to know. And then this domain and range, the concept of domain and range will be applied until the last topic of this course, because domain and range is close related to the function. Okay. Okay, let's say for example, suppose we have this equation. We have this equation, y equal to 3x minus 1. Okay, let's say we have this equation. Okay, please refer to this note. Yeah, I need to write this equation. Okay, let's say, for example, we have this equation. Please refer to page 1. We have this equation, y equal to 3x minus 1. Okay, this equation is also known as the linear equation. This is a linear equation. So y equal to again, y equal to okay, this one, y equal to 3x minus 1. This equation is known as a linear equation. Okay. Okay, in this equation, we have our focus now is on y and x. We have y here and also x. Y equal to 3x minus 1. For example, just for example. Okay, we have there are y and x here. We write y equal to 3x minus 1. What is y and what is x? In this case, in this example, x is an input, y is output. So this equation has one input and one output. Input x is x represent input, and whereas y represent output. We have input and output. X is an input number. In other words, we need one number to represent x. That's why we call it as an input number and output number. Input number and output number. That's the concept, the basic concept of function. In any function, there must be input and output. Okay, what does it mean by input? What is input? Basically, I think all of you know that, understand that. We need input to produce output. So the main factor here is input. Input will decide output. We need to decide what is input. how much money we have in order how much money, let's say, for example, is x equal to amount of money. How much money do we have? Do we need to buy something, to buy y, to get y? That's why we need to know the value of x uh, in order to get the output, the value of y. So in other words, we can say that to get y, we need x first. We need to identify what is x. That's why we call it x input. For any function, input is located at the right side of the equation. We have equation here. At the right side of the equation, there is an input, and output is located at the left side of the equation. So that's why we write y equal to what? Y equal to 3x minus 1. So the value of y is depend on the value of x. X can take any number from negative infinity to positive infinity, subject to the characteristic of the equation, the restriction imposed on the equation. Maybe there are some restriction, there are no restriction. That, in other words, what I'm trying to say is the value of x is what is the value of x? Basically, in general, we can say that x can take any value from negative infinity to positive infinity, real number. But at some cases, x only can take certain number, certain range, but that's subject to the what we call it, the characteristic, the structure of the equation. But in general, x can take any number. So the number of y is depend on the x. Okay, so this is about the input and output by definition. Now, in other words, we can also ask whether x only have one number. Can x have more than one value? For example, I said here earlier, x can take any value from negative infinity to positive infinity. The value of x could be 1, 2, 3, or more. So the value of x is depend on the structure of the equation. In other words, in other words, we can say that maybe the value of x, there are only one way, there is only one value of x equal to 1 only, for example, that maybe x can take more than one value, x equal to 2, 3, 4, 5, 6, 7, and so on. So in this case, we get the set value of input. The set value of input. X can take a group of value, one group of value. Maybe the group, the set, that kind of number, we call it as a set value of input. The set value of input, the set value of x, we call it as a domain. The set value of input, the set value of x. Maybe x can have equal to 1, 2, 3, 4, 5, and so on, depend on the structure of this question. So we can label this, the set value of x, the set value of input is a domain, whereas the set value of output, the set value of output y, output is equal to range. So we have a range and domain, input and output. Range refer to the y, domain refer to the x. Then the basic concept, you need to understand what is the difference between the domain and range. Range refer to the x, set of x. That's domain. Domain refer to the set value of input, set value of x. Whereas set value of output, that's equal to range. There's a what we call it, a term, label, range and domain. Domain is X, the independent variable, independent value, whereas range domain is for X for independent, range is for dependent for output. The value of output is depend on the value of input. The value of range is depend on the value of domain. That's the basic concept of input and output. Okay. For example, okay, if you refer to page 1, there are 2 examples. The first example is about the theory. The second example is about the application. Okay, let's say please refer to example 1.1. Let's say we have this equation, y equal to 3x minus 1. And then we have given in the equation the set domain of y, the set domain of the equation, the set of domain given the set of domain is 2, 4, 6. The set of domain 2, 4, and 2, 4, and 6. So what does it mean by this set? Okay, in this case, x could equal 2, x also equal 4, and x equal 6. There are 3 values of x. We assume that x only have these 3 values: x equal 2, x equal 4, and x equals 6. Okay, the set value of 2, 4, and 6 is domain. Okay, now we know x equal 2, 4, and 6, but how about set of range, the value of y? Okay, given in the equation there are 3 values of x. Let's say x equal 3, okay, equal 2, 4, and 6. What happened to y? Please remember, x is domain, y is output. If x takes one value, the value of y will change depend on the equation. Okay, now let's say x equal to what is y? What is the value of y? How to find y? We need to know what is the relationship between y and x. This one. Y equal to 3x minus 1. When x equal to y equal to, just replace, substitute x equal to the function 3 times 2 minus 1. 3 times 2 minus 1. 6 minus 1 equal to y equal to 5. Y equal 5. Okay, the second one, when x equal 4. So when x equal 4, y equal to 3 times 4, 12 minus 1 equal 11. When x equal 4. But now when x equals 6, we just substitute x equals 6 in the equation, minus 1. So y equal to 7. That's how to find the domain and range. Okay, so we have a set of x. Now we have a set of y. The value of y is 2, 11, and 7. Y has 3 values, but the value is subject to the x. 5, 11. 5, 11, 70. This set is the set value of y. The set value of y, we call it is as a range. Okay. Range refer to the set to the group value of y. Y have a few number here, maybe 2, 3, more than 1, 2, 3, and so on, depend on the situation. So we call it the set of range. Okay, that's how to explain domain and range. Again, domain is related to uh, x, whereas range is related to y. Domain for x, range for y. You need to remember this relationship, domain and range. Okay. The second example, please refer to the example 1.2. Let's say, okay, this one. Okay, suppose the revenue function of a firm is TR minus 100Q minus Q2, where TR is the total revenue and Q is the quantity of sale. Specify the range of revenue function if the maximum limit of sale per month is only 50. What is TR if the maximum limit of sale per month is 50? Okay. Now, this example is we show you how to relate the theory and the application. Okay, in the case, since I am an economic lecturer, my example is more on the economic situation, economic foundation. Okay, suppose the revenue function. Okay, what is revenue function? Anyone can help me to explain what do you understand about the revenue function? What is revenue function? What is the definition for revenue function? Anyone can share with us? Please explain about the revenue function.
It's how much money business earns. A business earns.
How much money business? Okay. I think that's correct. How much money business earn? When we're talking about revenue, that related to the business. For example, if you sell some, for example, let's say if you sell one books, let's say you sell 10 books. Let's say 10 books. The price of the book is, let's say, RM 3 ringgit per books. If you manage to sell 10 books, okay, the business you will get you will receive how much money? 10 times 3 equal to 30. Okay, this 30 we call it as the revenue. That is also equal to how much money the business earn. Okay, that the total revenue. Okay, this total revenue or revenue function is one of the concept that we will apply in this class, especially in topic one, and topic 5, 6, and 7. The term total revenue or revenue function. In this class, for mathematics, because this is a mathematics class, I will apply the mathematics concept, how to relate the theory of mathematics and the economy. For example, how to apply the mathematics in the revenue function. Okay. Okay, that's about the revenue function. Okay, thank you. Okay, let's say I have this equation, for example. Okay, please refer to page 1. Let's say I have this example. I have this function, the total revenue TR. TR equal to equal to 100 Q minus Q squared. We have two Q here, Q and Q squared. Okay, in mathematics, based on the mathematics theory, this function, since we have q and q squared, q and q squared, basically we only have one variable here. We only have a q, but we have two, what we call it, two type of q, two dimension of q, q and q2, q and q squared, q kuasa 2, q and q kuasa 2, q and q squared. Okay, so since we have q squared term here, this function is called as a quadratic. This function is called as a quadratic. I will explain later about this function in the quadratic equation section. Okay, now for today I will show you how to apply this concept in term of revenue, the function concept in term of revenue. Again, we have two variable here, TR and Q. We have TR and Q, but for Q we have Q and Q2, but it's still Q. The base is a Q. That's why we can say that this one as the LC. Sorry, this one is a Q and Q in this function in economic. Okay, before that, in economic, okay, again, Q is quantity. Forgot to explain Q. Q is quantity. Q equal to quantity. Maybe quantity sold, quantity produced. It depends on the situation. Okay. Now, how to relate this equation in terms of function, in terms of domain and range. If you refer to page 1, TR is total revenue, Q is quantity sold. The question asks you specify the range. Specify the range. The range of the function if the maximum limit of sale, maximum sale equal to 50 units. Q is quantities sold with maximum value of 50. The question is specify the range. Find the range of the equation. Determine the range of the equation. What is range? Again, what is range? Range in bahasa Melayu julat. In bahasa Melayu, we call it as julat. The range is julat. Range is also referred to Y. Range is julat. Range is referred to Y. This is also the set of range. This is a set of domain. So in this question asks what happened to the what happened to the range. We need to identify the range. What is range? Range refer to the Y. Now range refer to TR. So we know Y equal to Y to blah blah X plus C. Y is located at the left hand side. X is located at the right hand side. So Y equal to Y equal how many X, for example. So in this case, we need to find the value of X first before we can decide for range. The value of Q, or sorry, the value of X. In terms of total revenue function, now TR is range, and then of course Q is domain. Since we have two Q here, it doesn't matter because the base is Q. This also Q, or Q equal Q to the power of 2, Q cube, and so on. Okay. So based on this question, this question asks, please find the range of the revenue function if the maximum limit of sale is only 50 unit in a per month, for example. So we need to find the range. What is range? Based on the we have the information about the Q. Okay, the information about the Q. Okay, the value of Q based on economic. That's why you need to relate to this concept with the economic. I hope you have complete your macro, micro, and fixed economic. Okay. Now the question is about the domain. We need to find domain. What is domain? What is domain? Now domain refer to the variable that located at the right hand side. The input. The input. In this case, the value of the TR is subject to the quantity. Subject to the quantity. So we need to make we need to make some modification here. Okay, we need to identify Q. So in this case, Q is also domain, but now we have the maximum value of Q. The maximum value of Q, the maximum limit of sale per month is 50. Now Q. Now we need to identify the value of Q. Okay, we have the maximum value of Q is 50. The maximum value of Q is 50, but we don't know the minimum value of Q. The minimum value of Q. Okay, in economic, Q is quantity. Please remember, in economic, Q is quantity. Q must be positive. Q cannot be negative. Q must be positive. 0 and above. Q could be 0, but must be above 0. Okay, that's about the Q. But now we know that Q is domain. Q is represent X, but the value of Q must be positive. Since the question given the maximum value of 50, so the range for Q must be between 0 and 50. Cannot, because why I start with 0? Because the value of Q must be positive and above. Q never negative. So Q is quantity sold. Q is quantity sold or quantity produced. So we have the range of Q. The range of Q is the value of Q is between 0 and 50. So how to find range? We already have domain here. We already have domain here, but now we need to identify the range, the value of Y. But for this equation, the value of Y replaced by the value of Y is replaced by the TR. It's replaced by the TR. So we need to substitute Q equals 0 and Q equals 50 into the equation. For example, we have two value here for Q because Q is between 0 and 50. So we need to identify what is TR. What is TR? When Q equals 0, TR equal what? When Q equals 50, what is the value of Q? So since we have TR equal to what? TR equal 100 Q minus Q squared. That is TR. So we just replace Q equals 0 into this equation. When Q equals 0, TR equal to 100 times 0 minus the squared, yeah? 0 squared and minus 0 squared. The answer is 0. So when Q equals 0, TR must be 0. That according to the theory, the jumlah hasil total revenue is equal to P times Q. Is P equals 0, Q must also be equal 0 to maintain the relationship between M and P. Okay. Now the second number is 50. The second number is 50. When Q equals 50, what is TR? 50 squared. Must add squared. 100 times, oh, sorry, shit. Not one, this one, okay. Okay, 100 times 50 minus 50 minus 50 to the power of 2. The answer is, okay, please, okay, you need a scientific calculator in this class. Make sure you bring along your scientific calculator to the class, because you need the scientific calculator to solve the mathematical question. You are allowed to use the scientific calculator. Okay, when Q equals 50, TR equal to 100 times 50 minus 50 squared, the answer is 2,500. Okay, the answer is 2,500. What is these two value? 0 and 2,500 is the value of Y, the value of TR. The value of TR. So we can conclude here when Q is 0 until 50. Because why do we choose 50? Why do we choose 50? Because in question, the maximum limit of the maximum limit of sale is 50. That's why I choose 50. So between 0 and 50, the value of TR, the value of Y is between 0 and 200 and 250. So we can conclude that the value of TR is between 28 minus 2000, 28, oh sorry, not 28, 0 lah, 0 until 2050. That's how we explain the concept of TR in terms of domain and domain undulate. So that's how to relate the concept of mathematics. For example, domain with your to compare the function and the TR. In this case, show that we can apply the concept of linear, the concept of nonlinear, in order to find the relationship between any variable or any what we call it, any variable or any function. Okay, that's the basic concept of domain and Julat, domain and range for particular function. Okay, that's about example 1, example 1.2. Okay. Okay, this section B, I leave it to you. Please with this function. This just concept, how to apply how to figure the domain and function in terms of one-to-one, one-to-many, and so on. Okay, any questions so far?
No, sir.
Okay, the next part is how to represent this relationship, this function. How to represent? Because any relationship, any function can be represent in term of coordinate plan, or and then we have equation or sketch the graph. Okay, let's look. What is a coordinate plan? Coordinate plan is a titik coordinate. We have in bahasa, maybe you can say it's a titik coordinate. Okay, now we have, okay. So this this function, okay, this I would like to refer back this question. Y equal to 3x minus 1. We have a set of domain. This one, a set of domain, and set of range. Okay, set of domain and set of range. Okay, how to represent this relationship? If you refer to page 5, okay, refer to page 5. we can represent this relationship by using the diagram. We call it as a diagram. This diagram show the one-to-one relationship and so on. Let's say we have the value of domain and range. Each value of domain we produce one value of y. Okay, for example, let's say for this case we have if you refer to the page 1, we have the value of domain 2, 4, and 6. 2, 4, and 6. That this three number will produce the value of range y 5, 7, and 70. So this value, each value of domain will represent one value of range. That we call it as the one-to-one relationship. And then there is also one-to-many, and then many-to-one, and also many-to-many. All of them is also known as the relationship. Okay. If you refer to the page, this is quite this page is also explain about the difference between the function and relationship, fungsi dan hubungan. What is the difference between fungsi and hubungan? Sometimes maybe we say there is a function. Sometimes we say there is a hubungan. In a function, we have y and x. Y is a function of x. Then at the same time, one of you need we need to know the difference between the function and the relationship. Okay, basically when we're talking about the function and relationship, if you based on this page, the definition of function, the definition of relationship is a mapping from one set of domain to one set of range, with each element in the set of domain having one and more element in the range. Okay, that is the type of the relationship. For example, we have one-to-one. For example, one-to-one is also the relationship, hubungan. And then we have one-to-many. One domain could have two range, one or two range, one and more range, or we can also have the relationship in terms of the relationship of many to one. One value of x can share one value of y. For example, this case s1, s2 refer to share the value of x1. Or we have a relation many to many as shown in the figure 1.4. Okay, basically figure 1.1. 1.4, 1.3, 1.2, 1.1. Figure 1.1 until 1.4. This figure is referred to the relationship, whether it's one to one, one to many, many to one, or many to many. That's all it's about the relationship. But for figure 1.1, this is very special. 1.1. Okay, this figure only have one-to-one relationship. So this relationship is also known as a function. One relationship is also known as a function. Fungsi. Sebab dia ada hubungan satu dengan satu. Satu X, satu Y, satu Y, satu X. Dia tak berubah hubungan tersebut. Dan sebab kita panggil dia adalah sebagai fungsi. Okay. So in other words, there is a quite there's a difference between the relationship and function. Every function we can say every function is a relationship, is a relation, but all relationship are a function. Okay. Function is also subset of relationship. Okay, that's the connection between the function and relationship. Basically, function is refer to the one-to-one, 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 one-to-one input and output. Okay. The domain and output, the domain and range can also be presented by mapping figure 1 and figure 1 2, and also by the order pair or coordinate point. Let's say we look to the example 1.3. We have these three domain. This for x, this for y. Again, we refer back to the example 1.1. Okay, now if you go back to the example 1.1 here, okay, you should refer here. Okay, there is a connection between x and y. x2, y5, x4, y11, x6, I think y equal to 70. There's a one input produce one output. One input produce one output. Okay, this relationship or this function, this number, we have 6 number here. For x, we have 2, 4, 6. For y, the new number here, we have 5, 11, and 70. 5, 11, and 70. So now so this connection between x and y, when x equal 2, y equal 7. When x equal 4, y equals 11. When x equal 6, y equal 70. One x produce one output, or one y. One output produce one input. Okay, there is a relationship between x and y. So this combination x and y, we can put in a bracket. Let's say we put in bracket 2, 5, and then 4, 11, and 6, 70. Okay, This form, we call it as a coordinate point. This form is called as a coordinate point. We can form this, we can get the coordinate point of x and y. But remember, in this coordinate point, there are one value of x and one value of y. The first number is for x. The first number is for x. The second number is for y. That's the relationship. So to refer that, please, example 1.3, the relations or the connection between the relation between x and y can be the relation can be represented by the coordinate point as follow. As I write here, 2, 5, 4, 11, and 6, 70. 6 and 70. Okay, the first number, remember the first number is y, x. The second number is y, x, y, and x, and also y. Okay, that's how to represent the data. The first method we can draw a graph. The second method is about the how to this. Okay, so this part is about how to represent the data in term of the coordinate point. Okay, we can plot this coordinate point. Okay, we can plot this coordinate point. I hope you're familiar with this graph. In this graph, we have two vertical and horizontal line. We have a horizontal and vertical line here. And then the horizontal line is for input or domain. The vertical line, example, the vertical line is for y. The vertical line is the vertical line is for y. The horizontal line is for x. And that the line. Okay. The intersection between these two axes is, we call it as the value of this number is 0. And then we have the positive negative value of y, positive negative value of x. Be careful when you draw the line. Make sure you draw it correctly. Otherwise, you will losing your mark. Okay. Okay, for example, we have a 3 coordinate point before the 2, 5, 4, 11, and 6, 16. Now we just plot. This number, 2 and 5. This maybe 2, 4, 6, 7. This 2, 4, 6, 7. Oh, sorry. 2, 4, 6, 8. 2, 4. Okay, 2, 4, 6, 8, 7. Okay, let's say, for example, when x equal to, this is the point when x equal to y equal 5. We have the first coordinate point. The second coordinate point here, we have the second coordinate point is 4 and 11. I think 4 and 11. X equal 4. X equal 4. Y equal to 11. That's the second coordinate point. And the third one is when x equal 8. Oh no, x equals 6. X equal to x equals 6. Y equal to 70. Then again, we have 3 coordinate points here, 2, 5. The second one is 4, 11. The last one is 7, 6, 70. Okay, this one, all this one is called as a coordinate point. Okay, that's how to represent the data by using the coordinate point. Okay, the next one is we just pair the element. We just connect we connect the what we call it the coordinate point. For example, let's say I have again these 2 points. Then I take a ruler and just I draw this line. For example, I draw this line. We have this one. Y equal to this line is belong to y equal to 3x minus 1. And then basically they also the method to how to draw the line. At least you need uh, 2 course to apply this basically we need 2 coordinate point to generate this line. Now we have 3. That's why we have no problem to generate the equation y equal to 3x minus 1. Okay, that's about the how to represent by using the graph. Okay, let's skip here. That's the domain. Okay, the general form of function, usually the letters such as f, uh, f, g, h, f, g, and so on, can be used to name the function. Normally, I use f or y, depend on the situation. Assuming f, this one, represent the function defined by y equal to x plus 2, then the notation fx, we have a fx here, notation fx. With s of x is used to denote the output number that correspondent to the input number. Okay, so that we can say that if fx is equal to y, since y equal to x plus 2, so we can write here fx equal to x plus 2. That the gender form of the function. Okay, for example, let's say okay, for example, we have the question is find f3. Okay, what is find? What does it mean by find? In bracket 3. If fx equal x plus 2. Okay, this function refer to the situation where we need to find the equation that replace the input 3. That's why we have f3 equal to 3 plus 2 equal 5. That's it's quite easy here uh, to apply this concept, to apply this method in mathematics. In order to find the value of f3, we just type f to the power of 3. The answer is x plus 2. And then okay, that's the coordinate point. Yeah. Okay, what's next? Okay, this equation. Okay, please refer to example 1.7. We have one equation here. Basically, we only have one equation, but equation is structured. It's structured into three equations. Okay, please read the function carefully. Okay, that's page 7. Question is okay. Let's see how to read this question. I will show you. Please pay your attention here. Okay. Determine whether y blah 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 represent a function of relation. Function is referred to one, one domain and one output, one domain and one input and one output. Okay. How to read this equation? Okay. The first one, we read the first line. They say determine whether y equal to x if y equal to, let's say, I read this first, y equal to 2. Y equal to, I write here, if x greater than 1. If x greater than 1. Again, this function say that y equal to if x equal to 100. Okay. How to read this equation? How to draw this? When we want to draw this line, subject to, subject. Right. Okay, if x greater than 1, sorry, x greater than 1. If x greater than 1, 2 is maybe x equals start from x equal to and so on. So how to draw this line? Y equal to when x, if x greater than 1. Okay, the first step, we just draw the line. We just draw the line. Okay, I want to show you in the books, in the note, in the whiteboard. Okay, how to draw this line. That's it. Okay, let's say I paste here. Okay, now please refer to page 7. I have these two equations here. Okay, again, when y equal y equal to if x greater than 1. Okay, how to draw this line? Okay, now we have y-axis as usual. We have y-axis, x-axis as usual. Okay, now we need to put draw a line, the horizontal line when y equal to this one. When y equal to, I just take your ruler and draw the line. Okay, let's see. I just draw this line. Okay. When x equal to, but there is a restriction here. If x less than x greater than 1. So x greater than x greater than x is bigger than 1. So this function y equal to is valid when x greater than 1. So I need to erase this part. I need to erase this part. For example, let's say this part. When this function exists, this line exists when x equal is x greater than or greater than 1. Sorry, greater than 1. Now the line is only the red line here. The second one is when x equals 0. When x equals 0, sorry, y equals 0 when x equal 1. When x equal 1, y equals 0. When x equals 1, y equals 0. So we can plot here clearly this point. When x equal 1, so when so the y equal to if x greater than 1. Any value of x will produce the same value of y. Same value of y. X equal 10, x equal 1000, x equal 10,000, and so on. The value of y remains the same. Y equal to y equal 2. The second one, if x equals 0, y equals 0, x equals 1. X equals 0, y equals 0 if x equals 1. So we need to plot the area where x equal 1. This area, x equal 1. And y equal 0. The point is on the vertical line. The vertical line of the horizontal line of x. Okay. Then since there is only one point here, we just take the one dot here. One black dot here. Okay, the next one is when x less than 1. Okay, when x less than 1. Y will equal -2 if x less than or equal to 1. When the value of x is less than 1, the value of y is -2. So I need to draw the line for area where x less than 1. So this area, again, this area. Okay, now that's how to draw the line. But remember, we need to identify the dot for this type of equation. Normally they must have a one coordinate point, one dot where x exists and y exists. Okay, if you refer to this function say that y equal to only if x greater than 1. And then the second one, when y equals -2, only when x less than 1. But when x equal to 1, y equal to 0. When x equal to 1, y equal 0. So the value of y exists at this point only. The value of y exists when x equal 1. When x greater than 1 or less than 1, the value of y is not 0. The value of y have different number. That is 0. There is 2 and -2. So in this case, we draw the black dot, to show that at that point the value of y and the value of x exists. So that's why I put the black dot here. And then we have one point here. Okay, there's one point here. Okay, this point is also referred to. Okay, before that, at this point, this x equal 1, y equal 2. This is x equal 1, y equal 2. But at the second point, okay, let's the example. There's A, B, and C. I just add this label just to make it easier to explain this concept. Okay, at point A again, at point A, the value of y exists when x equal 1, y equal 2. But at point B, if I draw the coordinate point, this point is belong to x equal 1, y equal 2. X equal 1, y equal 2. This one is 1, 0, not 1, 2. But okay, please refer to point B. At point B, there is a coordinate point there. There is a coordinate point. X equal 1, y equal 2. But based on this function, when x equal 1, y must equal 0, not 2. So that coordinate point does not exist because the value is not, the value of x and y is not consistent with the function. So for this case, we cannot draw the black dot. That show that the value of y and the value of x increase. But for this case, at point B, the value of y does not exist. The value of y does not exist. Since we have, if we replace y equal to 1 into the equation, we have 0. The value of x, the value of y is 0. So at point B, we can conclude that this point, at point B, we must draw the hollow dot, the white or the white dot, show that the value of the function is not defined at that point. That's why we need to draw the white dot or the hollow dot to show that at that point the value of y does not exist. There is the value of z saja. The value of x only exists, but the value of y does not exist. That's why we need to draw the white dot. At point C, there is also another coordinate point here. This is referred to x equal 1, y equal to -2. Again, if you refer to the question, when x equal 1, y equal 0, not 2. Okay. And this line show that when c is less than 1, the c is less than 1, we can conclude here that at this point, we need at this line we need to draw the hollow dot to show that the value of y does not exist at the point. So that's the difference between A, B, and C. A, we need there is a black dot here because the y-axis, and then we have at point B we have at point A we have the black dot because the value of y exists, but at the point B the value of y does not exist, so we don't have the since the value of y does not exist, so we don't need to draw the the black dot or the black point. We just draw the hollow dot to show that the value of y does not exist at that point. There's a difference between the titik hitam and titik putih, black dot and black point or white point. Okay, so in other words, in this class, the black point represent we draw the black point when the value of y increase, the value of y exists, the value of y is valid. But if the value of y does not exist or does not valid, no need to, we just draw the white dot. Okay, that's the basic concept of the function. Okay, and then the rest of this part, I leave it to you. Please do your revision. Please read all the other parts. Most of them are based on the theory of function, but the main concept of this topic is about the domain and the range y and x. Okay, that's the part of the first part of this topic is about the function. Okay, any question so far? Any question? Please respond whether you have a question or not.
All good, doctor.
Okay, thank you.
Question.
Okay, that's all about the first part of this topic, the introduction about the domain, range, input, output, black dot, white dot, and so on. Okay. Okay, I think after this, the second part is about the linear function. The second part is about the linear function, the general form of the linear function. I think I will continue this part in the next meeting after the cuti perayaan. Okay, I think that's all for today. I think this section 1.2 I will continue in our next meeting after cuti hari raya. Okay, and then I hope I please note that I think yes, there is no lecture next week. No lecture because of the Hari Raya holiday, Hari Raya Aidilfitri holiday. In other words, that means our next meeting is on the for our next lecture is on 1st April at face-to-face at Pusanika 9. And then I will continue this section after cuti perayaan. I think the 31st is Tuesday. Okay, that is our next meeting is on 1st April 26. Okay, I think that's all for today. Any question before I close? I end this meeting for today.
No question.
Okay. Okay. For since this is online. Okay, your attendance for today is will be recorded. Will be automatically recorded by Teams. I will record this your attendance. I will download the list of the attendance automatically recorded by the team. I hope. Okay. That's why I hope you can stay please don't click the leave button. You just stay in this Teams until I click the end button. After that, after I click the end button, your attendance will be recorded automatically. Okay, that's all for today. Assalamualaikum and good afternoon. See you next 2 weeks.
Thank you.
Thank you, Doctor.
Thank you,
Thank you.
Doctor.
Okay, doctor.
Okay, welcome.